Okay, let's take a look at your lab and see if we can figure out how to do something like this. So we have a circuit that will have 4 inputs, I, J, X, Y, and 2 outputs, B and C. We're supposed to use a 4-variable Carnot map with don't cares to minimize the functions. The circuit has to implement all 3 of these functions. I and J are control inputs that select one function. X and Y are data inputs that determine outputs B and C. And so we have that. And we have these various different truth tables. So let's make up something that is similar to this. So let's say we had function f looked like this. R, S, B, C, 0, 0, 0, 1, 1, 0, 1, 1, and I'm just going to make some stuff up. Okay, and then function G, R, S, I'll go ahead and leave that one be. 0, 0, 0, 1, 1, 0, 1, 1, and I'll have this 1, 1, 0, 0, and function H, C, R, S, 0, 0, 0, 1, 1, 0, 1, 1, and I'll have 1, 0, 1, 0. Okay, so now, and we are told that we can assign I, J to whichever functions we want. Okay, so if anybody can tell me why with OneNote, sometimes like I have a touch screen and I'm trying to drag using my fingers. Sometimes I can scroll using my fingers and sometimes I can't, and sometimes it allows me to like add extra space here at the bottom easily and sometimes it doesn't. If anybody knows the answers to why what I'm doing wrong, I would appreciate it. Okay. And it didn't add that space that I just added. Okay, so let's decide what we want. Let's make function f be implemented with if ij equals 0, 0, function g be implemented if ij equals 0, 1, and function h to be implemented if ij equals 1, 1. That means that ij equals 1, 0 is a bunch of don't cares. Okay, so now let's see how did we have steps on here? Okay, so what this means is we're going to have a multiplexer. And we're going to have a multiplexer, a 4-to-1 multiplexer, and I and J are going to be our inputs to our multiplexer. And what goes into 0 is going to be F, and what goes into 1 is going to be G, and what goes into 3 is going to be H, and we can put whatever we want to into 2. And we have to figure out how to make those. So let's figure out how to make F. So F, let me look at B. Oh, I have two outputs. Okay, I need to keep that in mind. All right, so I have R, and we're supposed to use a 4-variable Carnot map. Okay, so let's do that. So let's make our 4-variable Carnot map. I'll have IJ here and RS here. 0, 0, 0, 1, 1, 0, 1, 1. And this is 0, 0, 0, 1, 1, 1, 1, 0. I have these backwards up here. And here are my functions. Why did they paste them way down here? I think OneNote has something against them. This is turning into one of those sessions where it's like nothing is working, and here I am recording and nothing is working. Now I can't select that. Okay. I can't scroll. If I weren't in such a rush, I would definitely stop this and start it. I thought that might be nice. Alright, so if ij is 0, 0, that corresponds to this row right here. Let's get b. So b is 0, 1, don't care, and 0, but let's make sure we get them in the right order. So 0, 0, so we're going to make this one for b, we'll do another one for c. So 0, 0, right here, b is 0, 0, 1, b is 1, 1, 1, b is 1, 1, b is 0, 1, 0, b is don't care. Okay, now if ij is 0, 1, b is 1 and 1 and 0 and 0. If ij is 1, 1, we don't care. And if ij is 1, 0, we also don't care. So let's see if we can get a good cover of this. So we only have to use the don't cares if they help us. And so it looks to me like the best way to get our 3 ones is that group and that group. And so I have that B equals, this group has J equal to 1 and R equal to 0. And this row has R equal to 0 and S equal to 1. So that's our function for B. Now let's get our function for C. So again, I have ij, I have rs 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0. And now I want to get C. So when ij is 0, 0, C is 1 for rs 0, 0, 1 for rs 0, 1, don't care for 1, 0, and 0 for 1, 1. C is don't care for ij 0, 1. For ij 1, 1, it's 1 when rs is 0, 0, it's 0 when it's 0, 1, it's 0 when it's 1, 1, and it's 1 when it's 1, 0, and this is don't care. So let's see, where are our ones and what's the best way to get them? It looks like we can do this and wrap around, and we can do this. So C equals, this first round group here has J equal to 0 and R also equal to 0. And this second group has, no, that wasn't J equal to 0, that was I equal to 0. Did I do that right on the one up here? Let's check. I did. Okay, so this was I equal to 0 and R equal to 0. And this group has I equal to 1 and S equal to 0. Okay, so now I have B equals JR plus RS and C equals I bar R bar plus IS. And just a reminder, I really don't know if this happens on yours or not because I haven't done it, but if you ever have X, Y bar or X bar Y, you can remember that that is an exclusive OR. And so that can save you from having to do lots of other gates. It's just the exclusive OR of X and Y, if that should show up. That did not show up for ours. Okay, let's go back and look at the instructions. Assign and specify in your design control input values for the functions. Okay, so I thought, when we started, I thought we were going to use a multiplexer, but now I'm not so sure that's the most efficient way to do it. Because our functions are so relatively simple. So, it does not seem like, I feel like in this instance, it's probably just easiest to do got I, J, R, and S, and I'll have B is the OR of J and not R. I love it when OneNote does that. J and not R. And you know what would probably be easier? Yeah. Oh, well, it's about the same. And not R and S. And C is the OR of not I whoops not I and not R, and then I and S. Okay, that's not so bad. So now I'm looking at this, since I have to actually implement this, I want to see if there's anything I can do to make it better. Like, for instance, I noticed that B, I could also write that as not R and J or S, and I don't know if that would be any simpler. So let me look at that and see if that's any simpler. I, J, R, S, not R, ANDed with J or S. That's B. And then I have not R ANDed with not I. And then I ANDed with S. And those ORed together, and that's C. Let's see, so that's one, that's 3 AND gates, 2 OR gates, 2 NOT gates, 4 AND gates, 2 OR gates, 2 NOT gates. It looks like this one is a little simpler, because this one had 1, 2, 1, 2, 3, just 2. But I feel like I might be missing a gate somewhere. Let's see. Nope, I think that's right. Okay, so I will implement this bottom one here. So so you can see it better. Let's make sure we do it right. Yeah. Uh, Okay, so I'm going to do this again, just make it a little bit neater. Sorry about the time, I know. So, let's quote. I in the middle, and R in the middle. And S here and J here. Okay, so then I have not R ANDed with J or S. To make B. I have not I ANDed with not R. And I have I ANDed with S. And then these two are ORed together, and that makes C. Okay, so I have 3 AND gates, 2 OR gates, and a NOT gate. Alright, so now we are supposed to design this Okay, so we are supposed to map these to chips. So let's look at how we're going to do that. So we've got the circuit drawn like we have here, and then we are going to figure out which chips we need, and then we're going to label it like we have here. And we'll see that when we look at the data sheets for the chips. So let's get the data sheets for the chips. If you have not already done so, you get them from the website. If we go to Lab Resources, data sheets for chips, you'll download a zip file, and then when you unzip it, you'll get the data sheets. And we need, rather than looking through all of them, I'm going to see if I can find what they are. Okay, so I want the inverter, so it's 7404. I want the 2 input AND, so 7421 dual 4 input, no, quad 2 input AND gate 7408, and quad 2 input OR gate 7432. Here's 7408, 7432, and 7404. Okay, so since it is my inverter, I could invert up to 6 things, and my AND gate and OR gate both have 4 AND gates and 4 OR gates. I only need 1 of each chip. And if I go back now and look at my instructions, and add appropriate pin numbers. So if what I will do is okay, so this is a little bit different from the other class. Okay, so I want to label which gates I'm using from the chips. So I go back to my circuit. And I will just go ahead and use 1 and 2 of the NOT gates, 1, 2, and 3 of the AND gates, and 1 and 2 of the OR gates. So let's start with the NOT gate. And if you look at our example, you put the pin number and the actual input and output. So like, let's take a look at that data sheet. So that's for the inverter. So the inverter is the NOT. And so 1A, and I know this, if I didn't know it already, if I scroll down, then I can see that 1A is the input, 1Y is the output, 2A is the input, 2Y is the output. And then if I look at my chip here, then I've got 1A is pin 1, 1Y is pin 2, and 2A and 2Y. So I'm going to just grab this. And put it here. So I can now say, if I'm matching it with this, so this will be 1A, which is pin 1, and this is 1Y, which is pin 2, and this is 2A, which is pin 3, and this is 2Y, which is pin 4. So that all goes with the inverter, which was 74SO4. You can't see it here. It's at the top of the page. So this is 74SO4. So, okay, now let's get the OR gate. So the OR gate, and here it is. And so I'll have, this will be 1A, 1B, and that's pin 1 and pin 2. And this is 1Y, which is pin 3. And this is 2A, and this is 2B, and that's pin 4 and 5. And this is 2Y, which is pin 6. And now our AND gate. See, it looks the same. That's 7408. So our AND gate, this will be 1A, 1B, and 1Y. And 1A is pin 1, 1B is pin 2, and 1Y is pin 3. And this is 2A, 2B, 2Y. 2A is pin 4, 2B is pin 5, and 2Y is pin 6. I'm sorry, the handwriting is so bad. And then lastly we have 3, so this is going to be 3A, 3B, and 3Y. And 3A is pin 9. Three B is pin 10, and 3Y is pin 8. Okay, let's see, have we done what we were supposed to do? Map the logic circuit to IC chips. List the types and numbers of gates you used in your circuit. I'll let you figure that out. Draw truth tables. Draw truth tables for B and C. You can figure those out as well. So, I mean, that's easy enough. So if we had, I'll do C for you. So, what does it say to do? Truth tables for B and C. Okay, so this would just be you have 16 rows. You have 1, 2, 3, 4, 5, 6, 7, 8 zeros. Okay, so we have that B is not R ANDed with J or S. So I'm going to make another column over here for J or S. J or S. So if either one of those is 1, so that would be 0, 1, 0, 1, 1, 1, 1, 1, and then not R. So you would not R would be the complement of R, so that's not R. So not R. So I would need both not R and J or S to be 1 in order for B to be 1. So in this first row, J or S is 0, so it's 0. Here they're both 1, so it's 1. Here J or S is 0, so it's 0, and so forth. And so you would fill it in like that. Okay, let's see what else we got. Truth tables. Did you combine terms between outputs B and C? If so, then explain details. If not, then how could you have done so? Let's look at our circuit and see if we did. I don't know. There's probably something with your particular functions where we could have used something in common with both of these. Like if both of these two had had a not R and S, then we could have used that for both our C and B. Our particular function did not, but the one that you do might. Okay, I apologize for this being so scattered, but hopefully it'll help you some anyway.